Hey everyone! Ever wonder how AI models like ChatGPT or GPT-4 keep getting smarter after they're first built? It's not just about that initial training. It's about something called post-training, where models refine their skills using feedback. But here's the catch. Traditional methods for this are slow, clunky, and hard to scale. Today, we're diving into a game-changing framework called AsyncFlow that's rewriting the rules of AI training. Let's break it down. Imagine training a giant robot to solve puzzles. You teach it the basics, but then you need to fine-tune its moves based on trial and error. That's post-training in a nutshell. But here's the problem. Most systems are like a factory line where one machine is overloaded while others sit idle. They're either stuck in one place, task co-located, or struggling to coordinate, task separated. It's inefficient, expensive, and limits how fast we can improve AI. Enter AsyncFlow, the ultimate traffic controller for AI training. At its core, it uses something called TransferQueue, a smart data manager that acts like a high-speed conveyor belt. Instead of waiting for all the data to be ready, it streams pieces of it to different tasks as they're needed. Think of it like a sushi restaurant, where chefs start preparing plates as soon as ingredients arrive, rather than waiting for the entire order to be placed. But here's the real magic: AsyncFlow's asynchronous workflow. Traditional systems force tasks to wait for each other, like passengers boarding a plane one at a time. AsyncFlow lets them run in the background, updating parameters with a tiny delay. Imagine a chef starting to cook while the ingredients are still being chopped. This reduces idle time and keeps everything running faster. And the results? Experiments show AsyncFlow boosts processing speed by up to 2 times compared to existing methods. That means faster improvements for AI models, lower costs, and more efficient use of powerful hardware. Plus, it's super flexible. It works with any training or inference engine, like a universal remote for AI. Why does this matter? Large language models power everything from chatbots to scientific research. AsyncFlow's efficiency means companies can train better models faster, reducing energy use and costs. It's not just about speed. It's about making AI development smarter, more scalable, and more accessible. So what's the takeaway? AsyncFlow isn't just another tech buzzword. It's a practical solution to a real problem. By decoupling tasks, streamlining data flow, and embracing asynchronous work, it's paving the way for the next generation of AI. Thanks for watching. If you want to dive deeper into the code or research, check the links below. Hit subscribe for more videos breaking down the science behind the tech. Until next time, ever wonder how AI models get smarter after their initial training? It's like teaching a kid to ride a bike. Once they've got the basics, you tweak their balance and confidence through practice. That's where post-training comes in, especially techniques like reinforcement learning, where models learn by trial and error, guided by human feedback. But here's the catch. These systems are like trying to build a skyscraper with a hammer and nails. They work, but they're slow, energy-intensive, and require way more computing power than we'd like. Enter AsyncFlow, a game-changer in AI training. Think of it as upgrading from a hand-cranked generator to a solar-powered grid. AsyncFlow uses an asynchronous streaming approach, which means it doesn't wait for everything to line up perfectly. Instead, it's like a factory assembly line where different parts work in parallel, passing tasks along smoothly. No more bottlenecks. How does it actually work? Instead of waiting for data to pile up in batches, AsyncFlow streams it continuously, like a conveyor belt. It also uses smart scheduling to tackle the most important tasks first, kind of like a chef prioritizing urgent orders in a busy kitchen. This isn't just about speed, it's about efficiency. The research team tested AsyncFlow against other frameworks, and the results were impressive. It handled bigger models, cut training time, and used fewer resources, without missing a beat in performance. It's like swapping a bicycle for a high-speed train. You get where you're going faster with less effort. But here's what really excites me. AsyncFlow isn't just for tech giants with supercomputers. By making AI training more accessible, it could democratize innovation. Imagine researchers in developing countries or small labs advancing medical diagnostics, climate models, or chatbots without needing a fleet of GPUs. The barriers are lower, and the possibilities are higher. So what's the takeaway? AsyncFlow proves that smarter design can make AI not just more powerful, but also more practical. As we push the boundaries of what AI can do, frameworks like this will be key to keeping progress sustainable and affordable. Thanks for watching. If you want to dive deeper into how these systems work, check the links below. And if you enjoyed this, hit that subscribe button so you never miss a deep dive into the science behind the tech. Until next time.